What all the topics we are going to see in static netlist verification is: first is netlist verification, then formal equivalence checking, and after that we are going to see static timing verification. So first, formal equivalence checking and static timing verification are illustrated with reference to the arbiter block used in the Bluetooth SOC design example. So they are taking an example of arbiter as an example, and they are performing equivalence checking and static timing verification on that. Okay, so we have seen that right from the beginning we are taking Bluetooth SOC as an example, right? So in Bluetooth SOC we are having arbiter. Okay, from that we'll see how they are performing equivalence checking and static timing verification. So first is netlist verification. So what they're trying to say is, in functional simulation, a design netlist is usually compared to its specification using test bench consisting of complete set of test vectors. So this is the normal, or you can say the traditional verification approach which will follow. What we will do, we will create a RTL, and in order to verify over RTL, we are going to design a test bench. So with the help of test bench, we are dynamically creating test vectors to the RTL, and we are verifying those things. So the design is tool or STA tool. Automatically they will perform the timing or verification on that. Okay. So it is less time consuming because we are not using extra labor to implement the test bench. We are simply using one tool, and it will tell you the whether you have achieved functional verification fully or not. And basically, if you are going with the static verification tool, you will maximum time you will get 100% coverage. Where if it is very difficult to achieve 100% coverage in functional simulation with the help of test benches. Now you see here, see verified RTL code. So this is above functional, means above RTL. Before we will implement an RTL, we will verify. After verification, when we are certifying that thing, that RTL is verified fully, then we are synthesizing that thing. Okay. So after synthesizing, we are performing scan insertion, clock tree generation, chip floor planning, and block placement. So you can see this is the normal ASIC flow. Okay, so here you see block placement, chip routing, timing verification. So this is the normal flow. So where we are performing that formal verification, you see here. After getting a netlist, right, here your RTL code. So you are giving these two input to the formal verification tool. You can see here. So you are giving two inputs, and you are taking cell library. Okay, what is this cell library? Actually, you need to give some properties and constraints. So we will see we have seen now where we are performing static verification. One is at RTL level and one is at gate level. Next, after getting a gate level netlist, you are inserting scan chain. Okay. So after inserting scan chain, again you will get one new netlist. So you are comparing that netlist with gate level netlist. Okay, so this is also equivalence checking and timing verification. So equivalence checking and timing verification means equivalence checking is formal verification approach, and timing verification is static timing analysis. Okay, similarly you have to perform that thing after inserting the scan chain. And after getting the clock tree, you have to back annotate that clock tree to the synthesis tool. Okay, and again you have to perform this verification, that is equivalence checking or timing verification. Okay, so these are the three processes, means three type of verification we are performing. So the three types of three places we are going to perform the static verification. Rest is timing verification, that we have to perform at each and every step. Okay. So equivalence checking uses a combination of binary decision diagram and tightly interacting algorithm called solvers to prove the two design views are equivalent. So now what they are trying to say, they are trying to explain from the tool perspective. Okay, in tool is going to compare, right, two netlist. How they are comparing? One is binary decision diagrams. Okay, so that tool has implemented with the help of these binary decision diagrams. Okay, and tightly interacting algorithm means you have to use many algorithms in order to perform that equivalence checking. So you can call that thing as solver. Okay. What is your objective? Your objective is to verify both, cross verify those. So that is only the objective. So EC is successfully used in many design houses for verification. So this is a normal term. So what all the steps are available when we are performing equivalence checking? Okay.